Sistem Operasi, Distributed Process Management, disadur dari William Stalling Operating System. The process migration. The motivation. Load sharing. Move processes from heavily loaded to lightly load system. Communication performance. Processes that interact intensively can be moved to the same node to reduce communication costs. May be better to move process. Availability. Long running process may need to move because the machine it is running on will be down. Initiation of migration. What is migrated? Must destroy the process on the source. Example of process migration. This is the picture of before migration. And this is the picture after the migration. What is migrated? Eager to all, transfer entire address space. No trace of process is left behind. If address space is larger, and if the process does not need most of it, then this approach may be unnecessary. What is migrated? Pre-copy. Process continues to execute on the source node while the address space is copied. Page modified on the source during pre-copy operation have to be copied a second time. Reduce the time that a process is frozen and cannot execute. Eager dirty. Transfer only that portion of the address space that is in main memory and have been modified. Any additional blocks of the virtual address space are transferred on the main. The source machine is involved throughout the copy on reference. Page is only brought over when referenced, as low as initial cost of process migration. Flushing. Pages are cleared from main. Negotiation of migration. Migration policy is the responsibility of starter utility. Starter utility is also loose. This is the picture of negotiation process of process migration. Eviction. Destination system may refuse to accept the migration of a process to itself. If a workstation is idle, process may have been migrated to it. Once the migration workstation distributed global state. Operating system cannot know the current state of all processes in the distributed system. A process example. Bank account is distributed. This is the picture. If at the first, this is the picture of it. All message in transit must be if clocks at the two branches are not some terms channel exist between two processes if they snapshot records of the state of process. This is the picture of consistent global state. This is the picture of the consistent global state. Distributed snapshot algorithm. This is the picture of the process and the channel graph. Distributed snapshot algorithm. Distributed mutual exclusion concept. Mutual exclusion must be enforced. Only one process at a time. When no process is in critical section, any process that this is the picture of model for mutual exclusion problem in distributed process management. Centralized algorithm for mutual exclusion. Distributed algorithm. All nodes expend equal effort on average in affecting Every node must be kept track of the global state of the system. The process is looking for a safe global state, checking processing overhead for a distributed system with a large number of processes. That is waiting for a message from another member of the group. When known in packets buffer space A unavailability of message buffer. For each node, the key to adjacent node in one direction is full with packets destined for the next. This is the picture of indirect store and forward deadlock. This is the picture of prevention.